My next guest on Tea Time is Sophie Harker, Senior Aerospace Engineer of Flight Systems at BAe. Sophie is part of this Engineering Day on the 3rd of November, created by the Royal Academy of Engineering to celebrate the role of engineers and engineering in improving sustainability. This week is also COP26, where global leaders have gathered in Glasgow to take climate action. Sophie talks about the developing technologies that she is working on to reduce carbon emissions. Inspired by astronaut Dr. Helen Sharman, the first British person in space, I found out more about her aspirations as a British female engineer. So Sophie, welcome to the Tea Time podcast with me, Ali Monjack. So it's Engineering Day this week, isn't it, on the 3rd of November? And how long have you been an engineer?
Yeah, so well, thank you for having me, first of all. So I've been an engineer for 7 years now, 7 years. So I joined BAe Systems back in 2014, so 7 years, yeah, and moved around on all sorts of different things and absolutely love it.
Brilliant. So, I mean, I know things have progressed, but, back at school, were there really those kind of options on the table for you to be an engineer in the STEM system, or not really?
Not really. So there was the sciences and the maths and thing. Obviously, I did a maths degree, so that was kind of always there and present. And I've shown promise for maths since I was a young girl. So that was often the thing that people who assumed I would go and do. But nobody really thought, oh, what about sort of the more applied maths? What about the engineering side of things? Because it just wasn't a thing that was really on the cards, which is a bit of a shame, really. And I don't come from like a STEM background. My dad's a carpenter, my mum's a teaching assistant in primary school, so it's just not the world we were in. And so I thought engineers are people that fix your dishwasher or your washing machine or your satellite dish, whatever it was, until I was 19. So quite late on did I sort of work out what engineering actually was.
But you were actually inspired, weren't you, to work at a place like BAe because of going to the Kennedy Space Center when you were 16. So describe that to me. What was the first? I mean, obviously, a lot of excitement.
Yeah, it was amazing. So I went with my family when I was 16 to Disney World, which I'm very excited for going back in a month's time. Very gonna be great. My dad dragged us all to Kennedy Space Center. And I don't think any of us really wanted to go, but we went. And I remember going around and just sort of being absolutely fascinated by sort of the sheer scale of things, and like not just how big things are, but how small things are, and how small like these little challenges they have to overcome are. Like if you're trying to drink water in space, like how do you do that without it floating away? Like silly little things like that those challenges I just got really inspired by. And then I watched a video about sort of where NASA wanted to go in the future, and there was a video of this woman on Mars, and she dropped like a photo of her family, and it basically said this could be you. And I remember sitting there at 16 going, yes, it could be me. That's exactly what I want to do. And decided I wanted to be an astronaut, and genuinely still do. It's still my life goal, as it were. And it kind of just inspired me down that route. And I was really lucky when I was about 19 years old, I got to meet Dr. Helen Sharman, who's the first British person in space. And she was the first person to ever say, this is what engineering is. Have you thought about engineering? It's not just, mechanics and overalls and oils. It's not that at all. It's you're inventing, you're creating the future. It's all those things. And yeah, I really credit that moment with her for getting me into engineering.
Yeah, it is completely. I mean, I've actually done an interview with somebody who's done a documentary on searching for Skylab, which I'm not sure if you're aware. Well, you probably are aware. Was actually the first international space station, wasn't it?
It was indeed, yeah.
Yeah, so that's really exciting. And all the technology and engineering that went into just taking them up into space in the first place to live there and explore. There's a lot of engineering that goes into that, isn't there?
And it's all those small challenges, and that kind of reads across into aerospace. And how I ended up in aerospace was finding out more about it and realizing that those challenges are very similar. You've got to overcome all those small things, like what happens if you move a switch like an inch to the left? Can you still use the switch when you need to use it? Like all those strange things that you just have to keep attacking and keep trying to solve. That's kind of like my lead into it.
Brilliant. So I mean, you first got your job at BAe System. So how long have you been there now?
I've been there 7 years. So I did an internship between my third and fourth years at university, because I did like an integrated master's in maths. I did a placement for 3 months, and then I joined as soon as I graduated in 2014. So 7 years with BAE now, moving across a whole host of different projects throughout that time.
Well, initially you started out as a flight path to do with space travel, didn't you, to do with the space plane?
Yeah, so I joined BAe on a graduate scheme. So at the time you could move around every 6 months and try different things. So I did a whole host of different things. Like I did aerodynamics placements for Typhoon. I did cockpit group work where I got to design elements of the cockpit for Typhoon, things like that. And then BAE invested in a company called Reaction Engines. And they're quite a small company compared to BAE, who are developing something called Sabre, which is the synergetic air breathing rocket engine. So it's kind of like a normal air breathing engine that you have on an aircraft, smushed together with a rocket engine, and then there's very special pre-cooler put on the front of it. And I got to go down there for 6 months and work with them, and work on their development for the Skylab space plane concept, which is a single stage to orbit plane. So it takes off from a runway, flies all the way into space, and then floats back down again onto a runway. So it was an amazing 6 months I had there. Really enjoying my time there. So I came back to BAE and was like, I've gained all this knowledge now. I spent all this time learning about this and working on it. I want to bring that back. So I got to stay at BAE working with Reaction Engines for the following 2 and a bit years, and working out what we could do with that technology and how we could apply it to spaceplane concepts, but also things like hypersonics, so traveling faster than Mach 5. And the statistic everybody likes to hear is getting to Australia in 4 hours and that sort of thing. Those sort of world that I was working on, which was so much fun. And one of my proudest moments, as it were, is working on that project.
So do you know how Sir Richard Branson's team have engineered his new spacecraft then?
I know bits and pieces about it, yeah, as much as I'm allowed to know in the public domain, because there will be a lot of very commercial sensitive secrets. I imagine, particularly with the race going on with Blue Origin at the time, they've been very protective over their technology, which is completely understandable. So yeah, it's an interesting concept. It is. So that's more sort of 2-stage to orbit, as we call it.
Somebody like me is not going to begin to understand it, but the point I'm making is, within your role, you have reached a stage where you can completely understand how it works.
So you can sort of understand the principles behind this, so why you would want to launch from another aircraft, essentially, which is what they do, and why you would want to take that route rather than just a standard rocket, or a special rocket in many cases to get yourself to orbit, but why you'd want to take that different approach. And there's many reasons, like the flexibility it provides. There's other reasons, sort of the safety sort of levels that it can provide, and things like that. So there's a lot of reasons why you would do it that way. So that kind of concept definitely makes it a more interesting news information for me to see how they're doing it and how far they get. So it was a very exciting day for me anyway, when they got to do that.
So, I mean, to go back to, how you initially started off with spacecrafts and flight paths, I mean, then you've moved on again, haven't you, to tackle something new?
Yeah, I did. Yeah, so about 2 and a bit years ago, I moved into something called Team Tempest. And so Team Tempest is like a UK collaboration with lots of different companies, trying to work out what the future of military jets will look like. So essentially what eventually will replace Typhoon in the future for the RAF and other militaries. So looking at a whole host of different things. My special area, as it were, was something called flight control system. So I kind of explain that as like the central nervous system of the aircraft. So it's the brain in the middle, it's the computer in the middle of the aircraft, it's all the moving bits, so your arms, your legs of the aircraft, as it were, and then it's all the sensors, so your eyes of the aircraft, working out how fast you're going, how far you're going, how high you are, those sort of things, and getting it all in together and to make it work together as a cohesive system. So it's like your central nervous system of the aircraft. And so I was looking at what technologies we need in the future, what we have now, what challenges we're going to face, and things like that, to create that whatever Team Tempest becomes in the future. So it was really good fun, really, really good fun.
So it sounds like another sort of area of engineering that you've had to learn. Obviously, physics plays a huge part in this, doesn't it?
Yeah, it really does. And like I say, like I didn't do an engineering degree, I did a maths degree. So it was a bit of a learning curve when I first brought it forward, as it were. But from there, it's kind of been a case of, okay, so it is impossible to know everything about aircraft. It's impossible to know everything about an engineering product because they're so complicated. So everybody is learning at some point in their career, and everyone learns throughout the entirety of their career. So what I really enjoy is taking on a new challenge and moving on to something and going, okay, so what can I add to this? What legacy can I leave in this project? And that's what I really enjoy doing. So I've now obviously moved again, as you know. So
yes. You've just said, so congratulations on your role. So yeah, do tell us more about it.
Yeah, so I've moved into a new area for BAe Systems air sector, as it is, so called electric products. So this is going to be a mix of different electric air vehicles, essentially. So the one that has been announced recently is a heavy lift drone. So it can lift 300 kilograms, which is an amazing amount for a drone to lift, which opens up a whole host of things. So not just for like military logistics, like carrying things on and off ships and things like that, but also things like emergency evacuation or medevac and things like that. So if there's people stranded places, or if there's a medical situation and you can't get the air ambulance there or whatever there, then you could possibly send one of these and literally airlift your casualty out, which is an amazing thing to be able to do. And my as I was saying, my very like eco warrior 12-year-old inner self is very pleased to be working on electric products, to be able to do something good for the environment and hopefully leave that legacy in that area now.
So I'm presuming, you know, to break it down to people who are listening, it's you're taking a lot of people out in one hit instead of, you know, keep going back and saying take 5 or 10 people out, lifting them out of an emergency situation, for example.
Well, it could still be 1 or 2 people at a time, but what it means is you're not putting anybody else at risk. So a drone obviously is uncrewed. There's no pilot on board. The pilots are elsewhere, or they're pre-programmed algorithms, so it knows exactly where it's going to fly, and it can go out there and rescue people from, say, mountaintops that you can't get to otherwise, or you're putting people at risk. Or it can get out to sort of like in the middle of warfare and go and pick people up from there, where it's a very dangerous place to be. So it just reduces the risk to human life by having those uncrewed drones, but obviously being fully electric, it gives it doesn't leave a footprint behind, which is even better.
Yes, and I mean it's COP26 at the moment, isn't it? I mean that's really quite something, and we've got a long way to save the planet. Obviously, you know, we're not the main perpetrators in the UK, but however, we need to get carbon emissions down to 1.5, don't we?
Yeah, and I'm very much a fan of the phrase "perfection is the enemy of the good." As long as we're doing something and we're moving towards, you know, a more sustainable future, then we're doing good things. And that's kind of where I view electric aircraft, electric products, and that sort of thing.
Yeah. So in terms of, you know, what you're working on now, as you said, you're really looking at the carbon footprint of you know, vehicles as well. So I mean, are you working with different energies?
I can't say too much at the moment, so I'm having to be very careful. So at the moment, we're the publicly announced project, as I said, with the heavy lift drones with Malloy Aeronautics, and that's mostly with battery technologies. So not many different fuels or anything like that. Mostly with battery technologies is sort of where we're at the moment. But like I said, I can't say too much about too many things, I'm afraid.
No, of course not. It is interesting though, isn't it? You know, with all this you know, energy crisis at the moment, with the lack of fossil fuels, but also, I mean, you know, what we have been using this year in terms of green fuels, such as, green technologies such as wind farming and solar power. Yeah. I mean, we just haven't produced the amount of wind, apparently, have we, or solar? So
yeah, entirely, and it's been a sort of a project within BAE for a very long time is particularly solar. We have an old runway of one of our sites that was disused and wasn't being used for anything, so we covered it in solar panels. So it's completely covered in solar panels now, and provides power to a load of our sites. But as you say, it's very much dependent on the weather. But it's a significant chunk we take out using it. So like I say, it's improvement, it's better, and hopefully more and more will be able to provide for it.
Yeah, so that is interesting. And I mean, there's a lot of talk about hydrogen at the moment, isn't there?
Yes.
Green hydrogen. So I only found out the other day that there's so many different types of hydrogen.
Yeah, it's something we used. Well, I say we that reaction engine is used for Sabre, the engine. That's what they use to power it. So it's a completely combustible product. So we completely burn it. So again, we can burn it completely, which means that the only thing coming out the back of that is water, which is an amazing thing to come out of a essentially a rocket powered engine, is just have water as your exhaust product. So there's a lot of things that we can use within aerospace with hydrogen, but one of the bigger challenges is actually getting hydrogen, because that's quite a power, well, it drains a lot of power to get hydrogen out of water, which is how most people create it. So it's where you source that power as well. So it's quite a complicated, like, you think you solve one problem and then it grows and grows and grows, and you're like, oh, I've got to get better energy from there, and I've got to sort that problem and solve that issue. It's not just a one shot, oh, we've replaced the fuel, if that makes sense.
No, I completely understand what you're saying. So I mean, there's many different elements, but having being an experienced engineer who's been working across 3 different sectors now, in the last 7 years, do you see that perhaps, I mean, I know you can't say definitely that we will be able to have a whole new system of air travel that just doesn't leave a carbon footprint?
I hope so. I really do. I'm optimistic about it. And I'm optimistic about the sort of, I don't want to say sudden influx, but the sort of the relative recent push for it in aerospace. And I think COVID has helped that. I think people have gone, oh, okay, so we've cut down on flying, and clearly it had a good impact on the environment. So we need to, as we bring it back, we need to embed the environment and sustainable element in that as we bring it back. So I'm really pleased that has been a positive outcome of sort of the hit that aerospace has taken over the last 18 months, 2 years. And so I am optimistic about the future in that sense. So I do hope one day that we can remove the need for fossil fuels in aerospace. I'm not on the phase of thinking, oh, it's never going to happen. I do think one day we will. How long that takes obviously depends on how much funding and things like that these projects get.
Yeah, absolutely. Yeah, so it'll be interesting to see. And of course, a lot rides on, the conference at the moment, and we'll see. I mean, there's been some tremendous speeches made by the Prince of Wales, and also Boris Johnson himself. So, yeah. So, I mean, what would you, as an engineer, like to see come out of it, this year's conference?
Yeah, I think a commitment to engineering. I know that sounds like a strange thing to say, but a commitment to actually engineering solutions, and not just a commitment to do something. Do you know what I mean? To actually say, okay, we recognize we don't have the technologies for these things, or we do have the technology, but it's small scale at the moment. So a commitment to really push those technologies through, I think, is what I would really like to see, because I think it is technology that's going to get us through this. It's technology that is going to help repair the planet and repair the situation we are in. And as aerospace goes, that could be electric aviation or alternative fuels, whichever way it gets to the market quicker, I think, is the main thing there. So we need to have a real commitment to those engineering solutions, not just, we need to do something. It's an actual doing something that I think we need the commitment to.
Yeah, so that we can still, live within the progress that we've already made as human beings, because, we do have the ability to travel across the planet or go into space, don't we? So,
yeah, I'm very much an advocate for the fact that green doesn't mean backwards. There's this sort of preconception that when you're going green, or when you're trying to reduce your emissions, whatever, you have to stop doing everything then, and we have to revert back to before we had aircraft and cars and that's not the way it works. We just need to find better ways of doing those things now, and I think that's the commitment I want to see, is just making alternatives for what we have. It's not going backwards, it's just going forwards in a different way.
Brilliant. Well, do you know what, Sophie? It's been amazing to talk to you. It really has. And, just to see an insight to your world as well, and how much you've achieved and what you're actually working on. I think, well done you. That's absolutely brilliant. It really is. So, last question. I mean, what are you inspired? I know this sounds, mad, considering you've just started a new role, but what are you inspired to do next?
Aspire to do next, yeah. So I'm excited to see where sort of I go with BAe Systems and electric products. I'm very excited about that. It's a new sort of area for BAE, so I'm very excited about this. In terms of sort of wider views, I'm very excited to see how aerospace recovers. Aerospace has been hit really hard, as I mentioned in COVID. There's been a lot of difficulties in wider aerospace. So I am excited to see how they embed sort of new technologies in their recovery and things like that, because you could have easily just gone, okay, let's just rebuild again the exact same thing we've already done, but most companies haven't done that, BAE included. So I'm really excited about that element of things.
Brilliant. So, and also, what would you say to a young version of you, looking out to go into engineering, especially from a girl's point of view, because it's still quite a male dominated world, isn't it?
It is, yeah, unfortunately, it is, unfortunately. But I think the advice I have for young girls and young boys really, but is follow what you're interested in. If you're really interested in space and aerospace and aviation, then go into that like I have. If you're not interested in planes and space, then don't go into it. That's not what it, but that doesn't mean that engineering isn't for you. There's so many different types of engineering. If you're really interested in laptops and computing and coding, that's a type of engineering. If you're really interested, I don't know, in makeup and cosmetics, there is engineering in that. Chemical engineering is very much a strong part of that. So whatever you're really interested in and passionate about, follow that, because engineering will get you there somehow, some way, and you'll be working on something that you really enjoy. And I think that's the best part about engineering, is you can touch any subject, any technology, anything in the world really, you get your hands on, and you can leave that legacy in there through engineering. And I think that's, there's no better job to do that in, I think.
Oh, brilliant. I can see you're really passionate. There's even engineering in food, isn't there?
There is indeed, yes, there really is. I believe food engineering is a course you can take. So yes, it very much is. Yeah.
Oh, lovely. Well, what are your plans for this week? Are you going to be celebrating Engineering Day in any way, or?
I've got quite a few sort of outreach and media opportunities this week, which I'm excited to do, because I always love sharing engineering. As you could tell, I'm very passionate about this, and I think it's important we talk about it more. So I've got quite a lot of those going on, and including I'm going to a school in person, which I'm very excited about, because that's not happened in a very long time this week. So so it's going to be very much a case of just celebrating it and sharing it with as many people as I can.
Yeah, and the younger generation as well. I think, as you said, going into school, they'll be so excited to hear about, everything that you've been doing as well to do with space travel. So yeah, that's brilliant. As I said, thank you so much for coming on today, and good luck and happy Engineering Day.
Oh, thank you. Likewise. Thank you for having me.
Okay. Bye-bye.
Bye.
Look forward to chatting with my next guest on the Tea Time sofa, this time next Saturday. In the meantime, if you would love to get in touch about having a chat with me, you can reach me on teatime@forthenow.co.uk, or you can find me on Facebook, Twitter and Instagram on Tea Time with AM. Bye for now.